Hello everyone, I am Dr. Aras Patel from LG Institute of Applied Sciences. Today I will discuss on Electrochemistry Unit 2 Paper 303 Physical Chemistry of Semester 5 as per Gujarat University syllabus. This is second video of Electrochemistry. In this video I will discuss on reversible-irreversible cell and reversible-irreversible electrode. Let us discuss on reversible-irreversible cell. So first thing, what is reversible reaction? If the cell reaction is always remain virtually in equilibrium state, this type of cell reaction is reversible cell. For example, this is diagram of galvanic cell or voltaic cell. Here the zinc electrode is dipped in ZnSO4 solution and act as anode part. It is attached to the copper electrode and dipped in CuSO4 solution via metal wire. And we supply the external current to the galvanic cell from the external battery. So this galvanic cell is always obeys three thermodynamic conditions in reversibility. The first condition is applied external current is less than 1.10 volt. That means EMF of the cell. It is 1.1. That means external applied current is less than 1.10 volt. So we observe three results. First one is electron is flow from zinc electrode to copper electrode and the current is flow in opposite direction. That means copper electrode to zinc electrode. And second result is zinc is oxidized into Zn+2 and dissolved in ZnSO4 solution. And Cu+2 getting 2 electron and converted into Cu as a solid form and deposited on copper electrode. Third one is oxidation and reduction reaction is take place in spontaneous. That means reaction is in forward direction. So reaction is zinc solid plus CuSO4 aqueous form. It gives ZnSO4 in aqueous form and CuS in solid form. Now in second condition, external applied current is greater than 1.10 volt. That means external applied current is greater than EMF of the Daniell cell. In this case, we also observe three results. First one is electron is flow from copper electrode to zinc electrode. That means electron is flow from copper electrode to zinc electrode and the current is flow in opposite direction. That means zinc electrode to copper electrode. Second result is copper rod is oxidized into Cu+2 form and dissolved in CuSO4 solution. And Zn+2 getting 2 electron and deposited on zinc electrode at the cathode part. And third result is oxidation reduction reaction is in reverse side. And the chemical equation is copper as a solid form plus ZnSO4 in aqueous form. It gives CuSO4 in aqueous form and Zn in solid form. In third condition, external applied current is equal to 1.10 volt. That means external current is equal to 1.10 volt. That means EMF of the Daniell cell. So in this case we observe two results. First one is no flow of electron as well as current. Second result is no chemical reaction is take place within a cell. So if any cell obey the three thermodynamic conditions in reversibility, then this type of cell is reversible cell. Now second point is irreversible cell. If cell is not obey the three thermodynamic conditions in reversibility, then this type of cell is irreversible cell. For example, the cell is composed of two electrodes, zinc electrode and silver electrode. Both are dipped in H2SO4 solution and we supply the current from external battery. So here we obtain two conditions. In first condition, if external applied current is less than EMF of the cell, that means E external is less than E0 cell, then the zinc is oxidized into Zn+ form with evolution of H2 gas. Then we get what chemical reaction? Zn solid plus H2SO4 gives ZnSO4 in aqueous form and evolution of H2 gas. And second condition is if external applied current is greater than EMF of the cell, that means E external is greater than E0 cell, then the silver electrode is oxidized into Ag plus form with the evolution of H2 gas. So we get chemical reaction is 2Ag plus H2SO4. It gives Ag2SO4 in aqueous form and evolution of H2 gas. So in both cases, the chemical reaction is not reversed. So this type of cell is irreversible cell. Now second point is reversible and irreversible electrode. So first one is metal ion electrode with respect to cation. In this case, metal M is electrochemical equilibrium with solution containing M plus N ions. That means, so half cell reaction is M is equilibrium with Mn plus N electron. There are some examples of metal ion electrode. So first one is Cu plus 2 is equilibrium with Cu in solid form. As it is, Ag plus aqueous is equilibrium with Ag solid form, and Zn plus 2 ion aqueous is equilibrium with Zn in solid form. So metal M that react with metal solvent. In this case, metal is equilibrium with metal ion solution. Now second electrode is amalgam electrode. So first thing, what is amalgam? Amalgam is the solution of metal in liquid mercury. In amalgam electrode, metal M is in equilibrium with solution containing M plus N ion. So the mercury does not take part in electrode reaction, and active metals like sodium, calcium can be used in amalgam electrode. Third electrode is redox electrode. Every electrode involves an oxidation and redox half reaction. Electrode whose redox half reaction is between two pieces present in the same solution. For example, platinum wire is dipped into solution containing Fe plus 2 and Fe plus 3. This type of electrode is redox electrode, and whose half reaction is Fe plus 3 aqueous plus getting 1 electron, and it is converted into Fe plus 2 in aqueous form. Fourth one is gas electrode. Gas is in equilibrium with iron in the solution. H2 gas is bubble over the platinum wire, which is dipped in acidic solution, and the platinum wire is coated with black platinum. H2 gas is chemised as H atom on the platinum wire. So H2 gas is equilibrium with 2H platinum, and it is equilibrium with 2H plus platinum in aqueous form plus 2 electron. As it is, the second example is fluorine electrode. It is platinum Cl2 gas oblique Cl minus is in aqueous form. So half cell reaction is Cl2 gas plus 2 electron, 2 electron equilibrium with, and half cell reaction is Cl2 gas plus 2 electron is in equilibrium with 2 Cl minus in aqueous form. Fifth electrode is standard Western cell. It is also called cadmium electrode. The Western cell is very useful as a standard cell to measure EMF, because the Western cell is independent of the temperature change. This diagram of Western cell, it is H-shaped glass tube. In left hand side, bottom part 12% cadmium and amalgam is filled, and CdSO4 8H2O is filled in over of CD amalgam, and in right hand side at the bottom part we fill the mercury as a solid form, and over it HgSO4 we fill here and solid CdSO4, and another part of this H tube and another part of this H glass tube is filled with saturated solution of CdSO4. The EMF of the Western cell is 1.013636 volt at 20 degrees Celsius temperature, and the d upon dt value is 4 into 10 is to minus 5 volt per degree, and it is used to calibrate the scale of potentiometer, and the cell reaction is Cd solid plus Hg2 plus 2 is equilibrium with Cd plus 2 Hg in solid form, and the cell notation is Cd oblique Hg oblique CdSO4 in 8H2O in solid form oblique with CdSO4 in saturated solution oblique Hg2SO4 and Hg. Now 6th point is Poggendorf compensation method. It is useful for the determination of EMF of the cell. Here, point A and B is the potentiometer wire and total voltage of the battery is supplied on the length of wire A and B. The cell is connected to the 3 kV and galvanometer and point D1 is noted here. The potential of the cell X is directly proportional to the point A and B. That means the potential of cell X is proportional to AD1 and the standard cadmium cell is connected to determinate null point D2. That means it is potential of the cell S is proportional to AD2 and we get the equation EMF of the cell X upon EMF of the standard cell is equal to AD1 upon AD2 and from this equation we calculate EMF of the cell X. Thank you.